Faster than the fabric of space-time itself, it can retain awareness of it, and it will essentially unravel. This is something that fills me with dread. At this point, our nighttime sky is shifting quickly, and in a few decades, or possibly even sooner, it could become entirely unrecognizable. Astrophysicists are raising alarms with experts like deGrasse Tyson confirming the unavoidable effects on Polaris. The story behind this shift is quite surprising. Polaris, known as the North Star, has long been a constant in our night sky, serving as a critical reference for astronomers, navigators, and stargazers. However, this might soon change, transforming our view of the sky and the study of the cosmos. Let's delve into the implications of this potential transformation. For many years, Polaris has served as a guide for sailors and astronomers, maintaining a consistent position in the sky. As a beacon, its steady presence has been crucial for navigation. But that stability might soon be challenged. In September 2023, a research paper from the prestigious Royal Astronomical Society raised doubts about the future of this stellar guide. Polaris is approaching a volatile stage where it could explode, potentially vanishing from the sky forever. The nature of Polaris. Polaris, or the North Star, is unique due to its proximity to the celestial North Pole. Positioned directly above Earth's northern pole, it appears almost stationary in the sky. It resides in the Ursa Minor constellation, also known as the Little Dipper. Polaris shines as a moderately bright yellow-white supergiant star, significantly larger and brighter than our Sun. However, Polaris isn't a single star. It forms part of a complex triple star system with Polaris A and Polaris B as a binary pair, while a third star orbits them. The gravitational forces created by these stars shape their orbits and influence their behavior. Any disturbances in these interactions could result in fluctuations in the star's brightness or pulsation patterns. However, the exact nature of these forces is still not entirely understood. Polaris lies about 323 light-years away from Earth, meaning that the light we observe from it today began its journey quite some time ago. Therefore, if Polaris were to explode now, we wouldn't notice it for over 300 years. It's even possible that Polaris has already exploded, and we have yet to observe the light from that event. Historical and cultural significance. Throughout history, the North Star has held cultural, navigational, and symbolic significance. Its steady position made it an invaluable guide for ancient sailors navigating seas and lands. Symbolically, Polaris has represented steadfastness and direction, remaining constant in the ever-changing night sky. For astronomers, Polaris has been a key reference point, assisting in the study of stellar movement and variable stars. As a Cepheid variable star, its occasional brightness variations have provided important insights into stellar properties and the nature of variable stars. This characteristic has also played a pivotal role in determining cosmic distances and calibrating scientific instruments. The anomalies of Polaris. Recently, Polaris has deviated from its regular behavior. This irregularity in its pulsation cycle has intrigued astronomers, prompting a deeper investigation into this strange anomaly. Instead of following its usual pattern, Polaris has begun displaying erratic dimming behavior, leading to concerns that the star may be nearing the end of its life cycle. This is consistent with behavior seen in stars nearing their death. The gradual extension of Polaris's pulsation period, which was once stable, can be attributed to interactions within its star system. There has been a yearly increase of about 4.5 seconds in the pulsation length. While this might seem minor, it has significant implications. Some astronomers suggest that gravitational interactions between the Polaris stars could be driving these changes in its atmospheric conditions, directly affecting its pulsation patterns. Others are more concerned that Polaris is nearing a critical stage that could lead to an explosion. Comparisons to Betelgeuse. The similarities between Polaris's behavior and that of Betelgeuse, another prominent star in the Orion constellation, are striking. Both stars have shown complex variations in brightness, raising concerns that they may be headed for a dramatic explosion. Stars in their final stages often exhibit such anomalies before they reach the end of their life cycles. NASA has expressed more concern about Betelgeuse, but formal attention has yet to be directed toward Polaris. As a Cepheid variable star approaches the end of its life cycle, It undergoes several stages, including the red giant phase and finally the supernova explosion. Given the irregular pulsations observed in Polaris, scientists predict that it has entered the phase of helium exhaustion, a typical stage for giant stars nearing their end. These irregularities in Polaris's behavior align with patterns seen in stars at the twilight of their life cycle. However, clear evidence of its impending supernova remains uncertain. Astronomers continue to monitor these anomalies to understand the fate of Polaris. Potential impact of a Polaris explosion. Should Polaris undergo a supernova explosion, it would likely be a massive event in the sky, possibly outshining the moon and remaining visible for days, weeks, or even months. Its brightness could dramatically alter our view of prominent constellations like the Big Dipper or Ursa Minor, in which Polaris plays an essential role. Rest assured, Earth would most likely remain safe regardless of whether Polaris explodes. Given its size and distance from us, while a Polaris explosion might not be as visually spectacular as Betelgeuse's, it could still be visible to the naked eye for an extended period, outshining nearby stars. Astronomers and observatories would undoubtedly take notice, sparking widespread interest within both the academic community and among stargazers. However, the impact on Earth's environment or ecosystems would be less significant compared to a closer supernova event. The fate of Polaris. What will happen to Polaris itself after a potential explosion? While large stars typically end their lives in a supernova explosion, this is not likely for Polaris. When a massive star goes supernova, it experiences a catastrophic explosion, marking the final stage in its life. This process involves the complete collapse of the core, triggering a violent shock wave that causes the star to explode. However, Polaris is not massive enough to undergo such a dramatic explosion. Instead, when Polaris exhausts its nuclear fuel, it will shed its outer layers and transition into a white dwarf. This process will not result in a supernova, but will lead to a more peaceful end as Polaris evolves into a small, extremely dense stellar remnant. A white dwarf is the dense core of a low to medium-mass star that has exhausted its nuclear fuel. It is incredibly compact, roughly the size of Earth, but as massive as the Sun. Once this happens, we will no longer observe Polaris as we see it today. Comparing Polaris to supernova events. Comparing the typical effects of Polaris's end to actual supernova events provides valuable insights into the evolution of stars and their ultimate fates. Observations of past supernovae, such as SN 1987A, and more recent events like SN 2011FA and SN 2014J offer key data for understanding what might happen to Polaris in the future. For example, SN 1054 led to the formation of the Crab Nebula, a cloud that continues to expand and radiate energy in various frequencies, providing astronomers with a rich field for study. Similarly, SN 1987A, observed in the Large Magellanic Cloud, offered insights into nucleosynthesis patterns, nebula formation, and the release of high-energy beams and radiation. These phenomena could shed light on the unique characteristics of Polaris. The formation of nebulae, like the Crab Nebula, results from material released during a supernova explosion interacting with surrounding interstellar gas and dust. This enriches the region with heavy elements and contributes to the cycle of star birth and death. While Polaris is unlikely to form a nebula, its final stages could still provide valuable data for understanding the life cycles of stars. Implications for astronomical research. The potential loss of Polaris as a reference point in the night sky raises fundamental challenges for astronomical research. Ground-based telescopes and celestial measurements rely heavily on Polaris for calibration. Its absence would necessitate recalibrating systems, affecting the accuracy of cosmic assessments. Additionally, the disappearance of Polaris could disrupt navigation systems and cultural practices based on celestial markers. For centuries, the North Star has been a symbol of guidance, stability, and resilience in various cultures. If it were to vanish, the shift could alter cultural narratives and the human experience of navigation and direction. Advancing observational technology. As astronomers turn their attention to observing Polaris more closely, advancements in observational technology are becoming increasingly crucial. Techniques like spectroscopy and photometry allow scientists to study light emitted by stars in unprecedented detail, detecting small changes in brightness that reveal underlying forces driving celestial behavior. These tools, combined with data from other Cepheid variable stars and red giants, will help refine models of stellar evolution. Studying similar stars offers valuable insights for understanding the mechanisms behind Polaris's irregularities. Furthermore, the study of triple star systems like Polaris and its companions could provide essential knowledge about how stars interact and influence their surroundings. This research has implications for understanding the formation and habitability of planets in such systems, advancing the search for exoplanets. Humanity's enduring curiosity. The mysterious behavior of Polaris highlights humanity's enduring curiosity about the cosmos. Understanding the conditions driving these irregularities is key to advancing our knowledge of stellar evolution and the universe's design. While the uncertain fate of Polaris challenges our understanding, it also inspires deeper exploration of cosmic mysteries. If Polaris were to disappear, its absence would serve as a poignant reminder of the dynamic and ever-changing nature of the universe. As astronomers continue to study its behavior, they seek not only to unravel the mysteries of this iconic star, but also to expand humanity's understanding of the stars and systems that shape our existence. Broader implications of Polaris's demise. The potential loss of Polaris extends beyond scientific and navigational concerns, touching upon humanity's philosophical and cultural connection to the cosmos. Throughout history, celestial bodies have served as sources of inspiration, markers of time, and symbols of stability in an otherwise dynamic universe. The disappearance of Polaris, the steadfast North Star, could have profound effects on how we perceive our place in the cosmos. Cultural significance. For centuries, Polaris has been a central figure in folklore, spirituality, and navigation. Native American tribes viewed the North Star as a guiding light, a symbol of hope and resilience. The ancient Egyptians used it to align the pyramids with the heavens, while medieval sailors relied on it to navigate uncharted seas. Polaris's position in the sky made it a symbol of constancy and direction, uniting cultures across the world in their reverence for the night sky. If Polaris were to vanish, it could disrupt traditions and narratives tied to its presence. Folklore and cultural stories would need to evolve, reflecting the loss of a celestial companion that has guided humanity for millennia. It would be a symbolic moment, a reminder of the impermanence of even the most seemingly unchanging elements of our universe. Navigational challenges. From a practical standpoint, the absence of Polaris would pose challenges for traditional navigation methods. Mariners and travelers have relied on its consistent position for centuries, and its disappearance would necessitate alternative celestial markers. While modern GPS systems have largely replaced celestial navigation, the symbolic loss of Polaris as a guide star could still impact those who continue to practice or teach traditional navigation techniques. Scientific recalibration. In astronomy, the loss of Polaris would force a recalibration of observational systems. Its role as a fixed reference point has been vital in the study of stellar motion, variable stars, and cosmic distances. Without it, astronomers would need to adapt their methods and develop new reference points for calibration. This transition, while challenging, could also spark innovation. The search for alternative celestial markers and the development of more advanced observational tools could lead to breakthroughs in how we study the cosmos. The scientific community's response to Polaris's potential demise would be a testament to humanity's resilience and adaptability in the face of cosmic change. Looking to the future, as astronomers continue to monitor Polaris, their efforts are guided by the same curiosity and determination that have driven humanity's exploration of the stars for centuries. Whether Polaris remains a constant in our night sky or transitions into a white dwarf, its story will continue to inspire new generations of scientists, stargazers, and dreamers. In many ways, Polaris's potential demise serves as a reminder of the transient nature of the universe. Stars are born, evolve, and die, leaving behind remnants that contribute to the ongoing cycle of creation. By studying Polaris, we gain a deeper understanding of these processes and our place within them. While the disappearance of Polaris may one day alter our night sky, it also opens the door to new discoveries and a renewed appreciation for the beauty and complexity of the cosmos. Humanity's enduring connection to the stars ensures that no matter what happens to Polaris, our exploration of the universe will continue.